Okay, we look at shearing stress. I'm going to copy the image over. So we look at positive shear, and then we have negative shear. Okay. So next we are going to look at how shearing stress is related in Mohr circle. Okay. So now if I were to draw an element, and then on our element, we have shearing stress acting in this direction. Okay. So we call this shear XY, and this is shear YX. And this is known as positive shear. Okay. This is known as positive shear. So this will be my point X. This will be my point Y. Okay. Then I'm going to construct Mohr circle. Or we're going to construct Mohr circle. And I like to declare that shear XY is equal to shear YX, and this is equal to positive shear. The way I've defined it, stress X is equal to stress Y, and this is equal to 0. Okay. So normal stresses is equal to 0. So from here, this is our normal stress. This is our shear stress. Element rotate clockwise, element rotate anti-clockwise. This arrow shows element what? Rotation. Okay. So we are aware that point X and point Y will land on the center. Okay. So over here, we know that this is stress X is equal to stress Y, and this is equal to 0. And for shear, we have to draw two lines. Okay. I understand it's positive shear, but we have to draw two lines. So this is your shear XY value, which is equal to shear YX. And directly below, right? This is your negative shear XY, and this is your negative shear YX. Okay. Next 2 minutes, no writing. Watch the screen. Repeat again. Next 2 minutes, no writing. Watch the screen. I'm going to put a pin on the center of the square. And we are going to focus on the shear stress that I circle in orange. Okay. Focus on the shear stress that I circle in orange. If we pin at the center, how will the element rotate? Anyone? Clockwise or anti-clockwise? Wait. I put my finger on the center. Given the orange arrow that I circle in orange, is it going to rotate the element clockwise or anti-clockwise? What do you say? Well done. Right? Counterclockwise. So when we declare that it's counterclockwise, is it the top or the bottom? That is your point X. Now let's look at the other arrow now. That I circle in purple now. Is it pink? Is it going to generate a clockwise or anti-clockwise rotation? Just by the pink arrow. Well done. With this, we draw our circle. From here, we can construct our Mohr circle. Are we clear? Okay. So in terms of shear, it has nothing to do whether is it positive shear or what. It all depends on the rotation of the what? The element. Are we clear? You have to grasp this concept. Whereas in normal shear, it's different. If it's compression, it's going to be on your which side? Left-hand side. If it's tensile, it's going to be on your what? Right-hand side. Okay. But pure science don't care. Civil engineers don't care. We have to care. Important as mechanical engineer to know this. Okay. Now, the next thing that I want to highlight now. Okay. I'm going to do negative shear now. Okay. So as you can see, negative shear goes this way. Okay. So this is negative shear. This is shear XY, and this is shear YX. And from here, we know that the shear stress XY is equal to the shear stress YX, and it is what? Negative. Stress X and stress Y are again both equal to 0. So now when both this is the case, okay, I'm going to draw my Mohr circle. Okay. So this is the normal stress. This is a shear stress. Again, I'm going to label this as my point X. And then this is our point Y. Okay. So assuming that the shear stress magnitude okay. So now let's focus on, firstly, focus on our point X, right? So if again, you put your finger on the center or a pin, right? The shear stress on the X waves will generate what sort of rotation? Clockwise rotation. So this is clockwise rotation, counterclockwise rotation. So now this is your point X, the one below now this over here will now generate a what? Anti-clockwise rotation. Okay. So, yep, anti-clockwise rotation. So this is your Y. And then this is your Mohr circle. Good. Today is a Friday. I want you to enjoy your class. You don't get this from textbook, unfortunately. Okay? I repeat again, you don't get this from textbook. Mohr circle is able to somehow predict the orientation of the fraction. Repeat again. Mohr circle can be used to predict the orientation of the what? Of the fraction. Bear with me. Okay? Hear me out. I discovered this by accident. And I tried to get this from textbook, can't find it at all. Okay? So now you all know how to draw Mohr circle. You all understand the concept of Mohr circle. So now, if I have an element, right, and I call this my X, and I call this my Y, and we only induce a normal stress in one direction, right? So in real life, what is happening now? Right? We induce a P and P prime. Okay. So now I'm going to sketch Mohr circle. Now you know that this is your point X and this is your point Y. Okay. So normal stress, shearing stress. Element rotate clockwise, element rotate anti-clockwise. Okay. So now from here, we draw lines. This is our stress X line. This is our stress Y line. Okay. And we know over here, this is your point X and this is your point Y. Okay. We construct a circle. This is our Mohr circle. And at our center of our circle, okay, at the center of our circle, is what we call our point O. Okay. Okay. So now, you all seen this before. I'm going to have this in stress X. Can you all see? And this is my point X. And over here, this is our point Y. And when I pull, the fracture somehow is aligned to our what? Point X. No rotation. It did not rotate. It stays what? In line with our point X surface. Yes or no? So i.e. point X relative to point O, right, has 0 degrees of what? Rotation. Agree? It did not rotate. Okay. So over here is also known as your fracture surface orientation. Okay. Now, The next thing that we're going to do is now we are going to induce what? Ay.